All right, now on to example number 7. Still rationalizing by conjugates here, but now we have a weird case where we have addition inside a radical. A little unusual, but the trick works exactly the same way. We specify also that x plus y is greater than 0, so that way we don't have to worry about that being a square root of a negative. And we also want it so that we have one more condition. And I didn't see this initially, but we do not want x plus y equal to 4. We don't want that. Why is that? Because if x plus y were equal to 4, if I just said, hey, look, this is 4 on the inside, then the radical becomes 2. All right? So like if I had 4 in here, we would have square root of 4, and that's 2, and then we have subtracted 2, and that ends up with a 0 in the denominator. Okay? So we also want that specification. That's important. All right? But it doesn't really change how we're going to do the problem. The problem is going to be handled the exact same way as before. All right, so rewriting the original expression, I have x over square root of x plus y, all inside the radical, minus 2. Okay. Here's the key trick, as always, multiply by the conjugate. So I have a minus 2 here. I'm going to change it to a plus 2 by multiplying top and bottom by x plus y plus 2 over square root of x plus y plus 2. Okay? Same trick, multiply by the conjugates. And then put parentheses around everything else so it's clear that we're multiplying. And then FOIL as much as possible. These two things are being multiplied, and they're quantities, so this becomes x times square root of x plus y. And then we have a plus 2x. All I did was FOIL this x through. I distributed it through this entire thing. That's where that came from. And now the denominator, I have square root of x plus y minus 2, square root of x plus y plus 2. Difference of squares. So we know how to handle this sort of thing. It's going to be this times this minus this times this. What does that give me? Square root of x plus y, quantity squared. And then I have a minus 2 squared. Okay, so continuing on, see what this gives me. All right, the top is pretty messy. I probably shouldn't have pushed that x through, but I'll just keep it for the time being. If you want to simplify it later, you can. Nothing wrong with that. And then now we have a square root and a square. These cancel. And we don't have to worry about putting the x plus y in absolute values because we said that x plus y is positive. We know that's true, so we don't need to put absolute values around there. If this specification were not given, you would have to put absolute value bars. So it's a little caveat right there. So this is just x plus y here in the denominator. Then we have minus 4. Simplifying. Okay, maybe I didn't want to push that x through because that kind of complicates things. I'm going to factor it back out. Sorry about that if that annoys someone. But math, you have to be open to making mistakes. So this is true. All I did was just pull out the x again. All right. And then the denominator, I can drop the parentheses because I'm not multiplying this x plus y times anything. So I just literally have x plus y minus 4 in the denominator. Okay. I can't cancel anything. These x's and y's cannot cancel for several reasons. Well, these ones can't because anything that's inside a square root or inside a radical is locked inside there. You cannot touch it from the outside of that radical. Okay, so you can't cancel these. Moreover, you cannot cancel this x and this x because this x is being added to stuff in the denominator. If it were being multiplied, like if this was a parentheses, then yes, you could cancel it. But because it's being added, these x's will not cancel. You are stuck with what you got. You need multiplication in both the numerator and the denominator to cancel. So with this, we are done with this example and done with difficulty 3, at least for the time being. we'll see what happens in the near future if I decide to add more and if you guys want me to do more.